Hey everyone, and welcome to This Explainer. Today we are unpacking a totally fascinating mystery that is literally hiding in plain sight, the secret scientific identity of everyday materials. I promise, by the time we finish up here, you are going to look at the world around you completely differently.
To kick things off, picture a completely ordinary bowl of breakfast cereal, with a bit of a twist, split right down the middle. On one side, you've got a standard white plastic spoon, and on the other side, a shiny silver one. Two spoons doing the exact same job, right? But they are made from entirely different factions of the material world.
And that brings us to a kind of wild question. Could there literally be metal hiding in your breakfast? We all know the shiny spoon is metal, but what actually makes it a metal? And for that matter, what makes the plastic spoon a non-metal? Where else are these materials just hiding in plain sight?
Okay, let's dive into this. Here's our roadmap. First, the Great Material Divide. Second, profiling the metals. Third, the non-metal counterparts. Fourth, a head-to-head comparison. And finally, testing like a scientist.
All right, part one, the Great Material Divide.
Look, materials are really just the physical stuff that objects are made out of. But humans don't just pick materials at random, do we? To choose the absolute perfect material for a specific job, whether you're building a massive suspension bridge or just molding a cereal spoon, you've got to understand its properties first. In the science world, we basically divide almost all materials into two massive, opposing rival factions, metals and nonmetals.
Moving right along to part two, profiling the metals.
So, what's our first big metallic superpower? Malleability. Basically, this means the material can be bent and hammered into shape without snapping. Imagine a blacksmith in a glowing forge just wailing on a piece of hot iron with a heavy hammer. The iron doesn't shatter, right? It gracefully bends and flattens to the blacksmith's will. That is malleability in action.
Next up, ductility. Metals are incredibly ductile, which means they can be pulled and drawn out into really thin wires. If you were to crack open the walls of your house right now, you'd find miles and miles of copper. And we use copper precisely because of this high ductility. It stretches perfectly into those flexible wires that power our whole lives.
They're also sonorous. It's kind of a fancy word, but it just means the material makes this clear, ringing sound, like a bell when you strike it. Think of a musician crashing a pair of brass cymbals together, or the chime of a gold coin dropping onto a glass table. That distinct, lingering ring, that's an absolute dead giveaway that you're dealing with a metal.
And the superpowers don't stop there. They are wonderfully shiny when freshly cut or polished. They are excellent conductors, so heat and electricity just flow through them effortlessly. And they are all solid at room temperature. Well, okay, there is one really famous bizarre exception, mercury. Mercury is this incredibly cool metal that's actually liquid at room temp.
Which brings us to part three, the non-metal counterparts.
Okay, so solid non-metals. They are notoriously brittle. This is a property meaning the material easily shatters or cracks when it's dropped or hit with force. Remember our blacksmith hammering away at that malleable iron? Well, if you took that exact same hammer and smashed it into a chunk of solid sulfur, which is a non-metal, it definitely wouldn't bend. It would completely shatter into a million dusty pieces.
You'll also notice non-metals usually have a pretty dull appearance. They just don't reflect light like shiny metals do. And unlike metals, a ton of them are actually gases at room temperature. Think oxygen or helium. They also generally have low melting points, but their most useful trait for us? They are terrible conductors. We call them insulators. We totally rely on non-metals like plastic to coat our electrical cords so we don't shock ourselves.
Let's jump into part four, the head-to-head comparison.
Now, what's really interesting when you compare them is the visual contrast. It's night and day. Metals are shiny. They bounce light back brilliantly when they're polished up. Non-metals, though, are dull, they absorb the light, and just leave this flat, matte appearance. Honestly, you can often categorize a material just by looking at how it handles light.
Then we've got the physical side, malleable versus brittle. This is all about how a material reacts to stress. Metals absorb stress by changing shape. They dent, they bend, they yield gracefully. Solid nonmetals, they reject the stress. They can't adapt, so their internal structure simply snaps, and they shatter.
So, if you want the ultimate cheat sheet summarizing these opposing properties, this is it. It perfectly maps out the whole thing. Solid versus mostly gas, shiny versus dull, conductors versus insulators. Grasp this chart and you can consider Lesson 5.2 officially complete. You now understand exactly why we make cooking pans out of superconductive steel, but we protect our hands with insulating non-metal handles. And finally, Part 5,
testing like a scientist. Let's say someone hands you a total mystery material. How do you interrogate it like a pro? Simple. First, look. Is it shiny or dull? Second, hit it. Does it ring like a bell or does it just crack? Third, bend it. Is it malleable? Fourth, feel it. Does it conduct heat away from your hand, making it feel cold? And fifth, test it. Does it conduct electricity?
To safely pull off that final electrical test, you just set up a really simple circuit. You connect a battery cell to a small lamp using some crocodile clips. Then you clamp those clips right onto your mystery material to complete the circuit. If that lamp lights up, boom, congratulations, you've got a conductive metal. If it stays totally dark, you've got an insulating nonmetal. So, let's take all this science out of the lab and drop it back into the real world. Think about a bustling outdoor market. At first glance, it just looks like a bunch of random stuff for sale, right? But with your new scientific lens, it's actually this chaotic, amazing laboratory of materials, properties, and really deliberate design choices. So I'm going to leave you with a bit of a challenge. Next time you're out and about, look really carefully at the scene around you. With Lesson 5.2 officially complete, you've got all the tools you need. Based on what might shatter, what can hold weight, or what conducts heat, which everyday objects around you are metals, and which are non-metals. The answers are everywhere, just hiding in plain sight. Thanks for hanging out with me in this explainer, and definitely keep questioning the world around you.